So with what we did on Friday, we know that we're going to start with our parent function and we're going to do some transformations, right? So take a look at our parent function would be what? Somebody tell me what my parent function would be of this. 4 is good. First part. 4 to the what? 4 to the x. Okay, so take a second. Before we start anything, we're going to just identify all of our different parts, right? So the parent function is always going to be b to the x. So that guy right there is our parent, right? 4 to the x. So in our table, we're going to write 4 to the x. That's our parent function. It's not negative 4. Remember, right? If there's not parentheses, it's not included. Our a is going to be what? -1. So make a note that our a is -1. Leave some room here so that we can write down what's going to happen with that. Okay, our a is -1 because of this negative right here. Right, our function is really -1 times 4 to the x plus 1 plus 3, right? So our h is going to be 1 or -1? -1, awesome. And our k is going to be 3. Right? A times b to the x minus h plus k. So we're going to systematically go through and transform our ordered pairs. And we are going to go through and we'll fill in our growth, decay, asymptote, domain, and range too. Right? We can do the asymptote right away before we forget. The asymptote is what? The a, the h, or the k? K. Asymptote is the same as the k. Remember, the k is our vertical shift, so that's going to help us figure out where our base, like our baseline is, right? All right, so our parent function, 4 to the x, let's get our ordered pairs. When x is 0, anything becomes 1, everything becomes 1. When our exponent is a 1, the value becomes itself, right? 4 to the first power is 4. And 4 to the negative first power is going to become 1/4, right? That's really the only one that you should have to possibly think about. And if you noticed as you were working on the problems from the other problems, you'll notice that a reciprocal type situation keeps happening. All right, so for a is -1, remember the a is our vertical stretch, right? So the a is our vertical stretch. That means our curve is going to either compress or it's going to stretch by a scale factor of whatever a is. So because it's vertical, our y coordinates are going to change. So it's going to be y times -1, right? You need to do a little x for times or parentheses or whatever. So we're going to, because the y value is going to change, it's going to be y times -1. So my x's are going to stay the same. My y's are going to be multiplied by -1. I'll do parentheses because that x is messing me up. Now the h is our horizontal shift, right? So it's my curve is going to shift left or right horizontally. So that means my y values don't change, but my x will change by -1. So it's going to be x minus 1. So we go to all of our x values and subtract 1 from the x values. Y values stay the same. Subtract 1 from the x value, y value stays the same. Right, because it's a horizontal shift. And then for our last one, our k, it's a vertical shift, so that's our up and down. So my x value will stay the same, but my y value will change. It'll go up by 3. So y plus 3. So x stays the same, y we add 3. Now when you get to the fractions, if you can't, like mental math, adding 3 to the negative 1/4, you might need to do a little work on the side, right? Like negative 1/4 plus 3. So again, if you can't mental math it, you can use a calculator and do decimals. However, be very careful if the fraction is like a repeating, like a third or a sixth or something like that, you're going to run into trouble with a calculator. All right. Now we know our asymptote is 3, so make sure that you mark that down on your graph. Use a dashed line. It's the only dashed line that you'll have. Remember, our curve stays solid. And our last set of ordered pairs are the what get graphed. All right, so graph those points. All right. Okay, so these are the points that are going to get graphed. And with some of these, it's going to be hard to kind of see like where the curve goes. You might feel like it looks like a straight line. It's not going to be a straight line, right? But this asymptote will help you because we know that it has to get close to this asymptote but not quite touch it. And our points here are kind of curving towards that dashed line. So I do know that as I draw this, it will get close but not quite touch it. And then I know this side is going to curve down this way. Okay, so try your best to make that look like a curve. My angle wasn't very good here. Yours should look better than mine. Will not make a V. It won't have any straight. It's going to always be a bit of a curve. This is going to appear straight. This will be the closest thing to like a straight line that you guys will have. And then we're going to talk about the other 3 parts of this. Okay, so growth or decay, and it says parent in parentheses. That's because the parent function can actually tell you whether it's a growth or a decay. If you look at the way that my graph is going, it does look like my graph is pointing down, which it is, but that doesn't necessarily mean it's a decreasing or a decay. Remember, if our curve moves away from the asymptote, it's a growth. Okay, if we think about what's happening as time is going on here, my numbers are getting further away from this flat spot. Okay, this flat spot means that my numbers are really, really small. Like they're tiny microscopic numbers. So these tiny microscopic numbers, even though they're going into the negatives, are getting further away from being microscopic like that. So that's why it's a growth. Okay, so anytime our curve moves away from the asymptote, it's a growth, right? And we'll come back to why the parent function tells us that. Now for the domain and the range, the domain are the x values that are included in our graph. So if we look at our graph, you should have arrows at the ends. Make sure that you're putting arrows on the ends. I've seen some people not do that. If you don't put the arrow, that means it ends where you end your line. Correct, it keeps going. So if we look at our x coordinates, this end of the curve is going to go on forever to the left. It's going to get close to 3 and never touch it, but it's going to keep going forever. On the other side, it's going to start kind of straightening out too. However, eventually it will cover every single x to the right. So it's actually going to include every x possible. So on the domain, just write all x values. Now the range is the y that's included, which y values are included here. My curve will continue down to the negative y's forever and ever and ever and ever and ever. However, on the positive end here, it's going to approach y equals 3, but never ever touch it. So all of the negative y's are included to infinity. Positive y's only go up to 3, but it does not include 3. So for our range, we're going to say 3 less than y, but not including y. So the y's are going to be, oops, wrong way. Sorry guys, scribble that out. Y is going to be less than 3. Sorry guys. I should have started with the smallest numbers. Let me zoom in on that for you. So it's going to include negative infinity. Okay, that's a negative infinity. So negative infinity to y, and then approaching 3, but not including 3. Okay. All right, so if I look at my graph, my smallest numbers are going to be negative infinity numbers, and then it's going to approach 3, but never touch 3. All right. Okay, we're going to do one more. Let's jump to 12. 12 will be a quick one. All right, so 12. We have less columns, which means that some of our numbers aren't going to be listed here, but our parent function is 1/2 to the x. Make sure you put that in parentheses when you rewrite it here, because if we don't, then it's just 1 to the x, right? Our a is what? -1. And we have an h, it's there, it's just 0, so we don't need to do anything because our h is our vertical shift. If our vertical shift is 0, it's not shifting. But we do have a k, and it's -3. Our k is also our asymptote. So let's label that while we can before we forget. And then we'll start going through, and if we have 1/2 to the 0 power, always becomes 1. Anything to the first power is itself. To the negative first power, you might not need to write anything off to the side. Oops, no, it's not. Except I just wrote that down. I was writing what you were saying. So it's 1 to the negative first over 2 to the negative first, which becomes 2 to the first over 1 to the first, right? Which becomes 2. What you should notice is when you take that parent function and you have your exponent as a -1, you should get the reciprocal of the base. So if you guys look at all of your first columns, you should find that when the exponent was -1, you should get the reciprocal, right? You guys see that? Like on number 9, the parent function was 1/4 to the x, and our ordered pair was -1, 4, right? You're going to get the reciprocal. And if you don't remember that, it's okay. You just have to do the work off to the side. All right. So now our A is going to be a vertical stretch or compression or shrink. So we multiply, right? If you guys remember, we noticed that on that like first activity of this paper on Friday. So we're going to take our y and we're going to multiply by -1, right? So our x value stays the same, y gets multiplied by -1. So remember our vertical stretch or shrink is like we're applying a scale factor. A scale factor of -1. Yes. Okay, give me just a second. And then do the last column. So K is our vertical shift. Remember, H is the horizontal, K is the vertical. So that means I'm going to take my y coordinate and subtract 3 from it. X stays the same, y subtract 3. So we should get -4, -3.5, -5. Make sure you're being careful with your positives and negatives, right? If you're not, these are all going to be wrong. Okay. So remember, we're only graphing the last column. Right, these in-betweens are just the points in our transformation. Our asymptote is -3, so make sure that you identify that with your dotted line. And it's going to look a lot like a straight line, but it's not. Remember, we always curve towards the asymptote or away from it. Do as best you can. It's a little tricky. Yes. Now, as for the growth or decay, again, I know from left to right it looks like it's increasing, but because it's getting closer to the asymptote, it's not, it's decaying. These numbers are getting closer and closer and closer and closer to like our baseline or our 0, basically is what it is. So this is a decay. And if we look at the parent function of what we've done so far, when our parent function has a number bigger than 1, so if you look at like 8 that we just did, that was a growth. Our parent function was 4. I don't have them on my papers. I don't know where my paper went, but if you look at like 7, your graph for 7 that we did on Friday was a growth, and our parent function had a base that was 2. So what you're going to notice is when your base of your parent function is a fraction, if it's between 0 and 1, you're going to get a decay. When your parent function base is 1 or higher, you get a growth. Okay, so when the B, and I think you might even have this in your notes, When the b is 1 or greater, you get a growth. And if your b is between 0 and 1, or like a fraction, you're going to get a decay. That might be something that it takes you a little bit to kind of get the hang of, but there will be a point that without graphing, you're going to have to describe these kind of things. You're going to have to be able to look at the function and tell me right away, is it a growth or decay? Is it going to be drawn below the asymptote or above the asymptote? And if you remember, the a being negative creates a curve underneath the asymptote. If you look at number 8 that we just did, see how on number 8, the a was a negative and our graph was below the asymptote? The other ones that we did on Friday, when the a was positive, our graph was above the asymptote. So those are the kind of things you're going to need to kind of have an idea about. As for the domain, it's our x's. You're going to find that with these type of graphs, your domain will always be all x values. Our range is going to include y's that are at the negative infinity all the way up to negative 3. So negative infinity all the way up to negative 3. All right, yes.
Would it be negative infinity is less than or equal to
1? No, because y is going to be, this is showing that y is in between negative infinity and negative 3. Huh? It will never hit negative infinity because infinity is forever. That's just the way we write it when we show this is in between these two values. There is no actual number for negative infinity, so like we can't, like y is not going to be less than, it's greater than negative infinity. That shows in between. Okay. So what you guys are going to do now is on the next page, you're going to do numbers 1 through 6. All right. So on this page, a couple things you guys are going to notice. You have 3 columns for every single one, but you may not need all 3, just so you know. So if you get to one where you're like, I don't need the 3rd column, you're not doing something wrong. Okay, you might not need all 3. We just put 3 there to just cover all the bases. All right, so make sure you get the growth, decay, the asymptote, get each of your columns, show the transformation, and that's it. All right, any questions? Domain and range too. And remember, the range is going to be an in-between, so your y is going to be in between 2 things. One will be an infinity, a negative or a positive. The other one is going to be the asymptote. And the domain will be all x values. All right, you guys.